Okay, so the next problem in the lead code we are solving is contains duplicates. Okay, so basically we have got a list of numbers. We need to identify if it has any duplicate items or not. Okay, so let's see how we are going to solve this. There are multiple approach of doing it, but let's see that how we can approach this problem. So first thing is, let's take the same example, which is 1 2 3 and then 1 again. Okay, so here you can see there is a duplicate item, right? 1, but we'll see like how we can do it programmatically. Okay, so first foremost thing what we could do is we can simply sort this one, correct? So let's say that if I'm going to sort this one, right, how it will look. um Second, okay, let me sort it out and write it. Okay, so once I sort, it will look like this: 1 1 2 3, right? So once I sort it, I can just simply compare the neighbor elements, right? So we know that once we sort, like, I mean, alike same elements will come side by side, correct? So once I sorted this array, so these are same elements. So whenever I compare the neighbor elements, if both are same, it means that it contains a duplicate element. I can simply return it as true. Okay, that is one way of doing it. Or what we could do is we can take one as a reference. Okay, so let's say that I am going to see, for each of the element I need to see if there is a duplicate element or not. Okay, so let's say I will take this as one as an example. What I will do is, next I will check 2. Okay, I will compare it with the 2, and I will compare with 3, and I will compare with 1. Okay, so we found a duplicate element here, correct? So we found a duplicate element, so we can return it as a true. This is one way. So basically in this case, what you will notice, you will have to iterate compare for each element, right? You will need a for loop, one for loop, to just check, to compare for everything. Okay, that is one for loop. In the inside one more for loop, you will be checking for the rest of the elements. Okay, for the rest of the element you will see if there is a matching or not. Okay, so for one you will be checking with 2 3, and then one you found it. Okay, so let's say that I'm going to change this to 3. Okay, I'm going to change this to 3. So what happens, like, I mean, we'll be comparing this with the rest of the numbers, it will not found. So when I'm comparing with the 2, it is not found, but when I'm comparing with the 3, we will find it. Okay, but okay, yeah, this is one way of doing it. But yeah, again, right, it is increasing the time complexity, because we are iterating through the list again and again, right? This is also not a very good approach to solve this problem. Okay, so now let's see that how we can improve the performance of it. Okay, so again, here also the time complexity wise, right, here we have sorted it already. Here we have sorted it, and then we are doing the comparison again, right? It is also increasing. That sorting will have its own time complexity, and also comparison will be iterating again, right? It adds some complexity again. Okay, now let's see that how we can simply improve the time complexity of this problem. Okay, so basically we need to avoid multiple iteration. For that, it means that we need to, what we can do is we can store what is already seen. Okay, so let's say that I'm going from 1 2 3 1. Okay, so if when I'm here, if I already know that if I visited 2 before or not, I can say this is a duplicate, correct? So let's say that for here 1, right, when I reach here, let's say that I'm going to iterate from left to right, and when I'm reaching here, if I knew one already, if I had visited 1, I can simply declare this as a duplicate, correct? So that's what we are going to do here. So let me rewrite the example here. Okay, 1 2 3 1. So what we are going to do is we are going to iterate from left to right. Whenever we visit a new node, we are going to store it in some data structure. Okay, we'll see which data structure that we are going to use. We are going to use a data structure that is efficient for searching. Okay, so basically, because when I visit the 1, so I will be putting it 1 here. Okay, I will be inserting 1 here, and then when I visit the 2, I will be looking up if the 2 is present in this data structure or not. Okay, so for that, lookup is speed lookup is important. Okay, so we will see like which data structure will help us in storing this data, and also with retrieval part. Okay, so now coming to this example, so I will come here 1. So like, I mean, do you find this in the existing data structure? As this is empty, there is nothing, so I will just add it to here. Okay, we'll say this as a visited or found or anything like that. Okay, so 1 is not found, we will store it here. And when I go here, I will look up in the data structure to see if the 2 was present, or if 2 was already visited or not. Okay, 2 was never visited, right? I don't find it here, so I will add it to the visited. Okay, when I go to 3, it is not found, 3. And finally when I go to 1, when I ask this data structure to see, like, I mean, to check like if 1 is present or if it is already visited, it will say that it will say that okay, it is already found. Okay, so it means that when it is found, it means that this is a duplicate element. Okay, sorry, the arrow mark went wrong. Okay, this is a duplicate element. Okay, so it means we can just simply return this answer as a true. Okay, so in this way, so we iterated only once. Okay, but the space complexity will increase because we are declaring one more data structure and we are storing it, right? We are also copying it almost. So it will, the space complexity will increase, but at least we are not duplicating what we are doing. Okay, so we will be iterating only once and we'll be doing the search, and based on it we are going to declare it as a duplicate or not. Okay, so basically we have discussed the three approaches here. One is sorting. This we know that it will also increase the time complexity, and also the two for loops. Okay, comparing taking reference of one and comparing with the rest. And the most efficient to solve this problem is this one. Okay, we are going to as we iterate from left to right, we are going to keep a track of an element. Okay, we are going to put it in a visited nodes. Okay, and when we encounter that element, right, we are keep on looking if it is already, if we have already visited this element or not. Okay, if it is already visited, then we can simply return it as true. Okay, now let's check the code how it looks. Okay, so it's a straightforward thing. So for the lookup, right, for lookup we are going to use the set. Okay, we could have used the list also, but compared to in Python implementation, right, like by the list and set, the search operation, the in operation will be faster for set. So we are, that's why we are going with the set. Okay, so what we are doing is, firstly we'll initialize it as an empty, and then what we are going to do is we are going to iterate each of the elements. Okay, and if it is not found, we are adding it to the data structure. Okay, we are adding it to the data structure. If it is found, we'll say that okay, duplicate found, return true. Okay, and there is a case that if it is not found, right, we, if we checked for all the elements, if it is still not, if it didn't find any duplicate elements, we can simply return it as false. That's it, the straightforward thing. Yeah, that's it. Thanks.